Hey, what's up guys? This video is for section 9.1, which is graphing quadratic functions in standard form, and it is a short version. If you guys want to watch my full version, the full lesson for this section, you guys can go and look at my playlist for Algebra 1 in my YouTube channel. So first, let's go ahead and understand what is the standard form. The standard form for a quadratic function is y equals ax squared plus bx plus c. Some people say quadratic equation, some people say quadratic function. The thing is that you guys need to know it is a quadratic because the highest exponent of the x, this one here, is 2. So that's a degree of 2. So we have a quadratic function. Here, I want to state what is the pattern of the quadratic function. We'll talk about that. What is the vertex of the quadratic function? We'll talk about that. And the maximum or minimum, which is the vertex, but it has a name. And we want to state the domain and the range of the function. So first of all, let's go ahead and look at number 1. If you guys look at the function or the equation, number 1 is y equals x squared minus 2x. Notice what I've given you guys to help you find the components that you need to graph the function or the parabola. That is the name of the U shape that we are going to make when you guys graph a quadratic function. First, we have an x. X equals negative b over 2a. This formula here is to find the x coordinate of the vertex of the function. So we have this one. This, notice I have a little line here. That's the division line. So you guys are going to substitute the b and the a into the formula. You guys substitute here and then you guys simplify. So this is kind of set up for you guys to do the work, fill in the blank, and you guys find the x value. Then when you guys find the x, you go back, substitute into the function and find the y value for the vertex. That is the y coordinate. So on the bottom here, I do have v equals, and you guys have empty coordinate points here. That's what we need, x and y for v, the vertex. Then I'm going to use the axis of symmetry to actually draw a dashed line so we know where the parabola is cut in half. Then you guys are going to find the y-intercept, and we'll talk about that also. Then you guys are going to use what I like to say a pattern. Now this, kind of like a cross, you guys are going to use the pattern 1, 1, 2, 4. That is a pattern that comes from the parent function of the parabola or the quadratic function. We know that if you guys want to find more points on the parabola, you guys can use the vertex. Then you guys can use the pattern 1, 1, 2, 4 to find more points on the parabola. So let's go ahead and look at number 1 or do number 1. So first of all, I need to know which one is my a value and my b value. So and my c value, if you guys want to also find out what it is, you guys need to know that a is the one with the x squared. So my coefficient in front of the x, we have an invisible 1, that is my a value. B is the one with the x, not the x squared, just the x, regular x with an exponent of 1. And c is the one at the end. Now notice that here we don't have anything at the end of the function. So that is my c. So you guys can say that c equals 0 in this case. But guess what? We don't really need c for the vertex. We need b and a. We are going to use c, but it is a good idea to know that c equals 0 in this case. So I'm going to substitute b and a into the actual x formula, or b negative b over 2a. So I have a negative b. Notice I'm using parentheses because I'm going to have double negatives, and b is negative 2, and the bottom is 2 times a. You guys are going to simplify, so we get positive 2 over 2, which equals 1. So my x value equals 1. So my vertex down here, guys, I'm going to use 1 for the x value. Now I need to find the y value. So I'm going to go back. I'm going to substitute this into the x right here, and then I am going to find the y value. And I already did that for you guys on the screen here. I substitute 1 into the x. So there's a 1 squared minus 2 times 1, and that equals negative 1. So my y value for the vertex is positive, nope, not positive, negative 1. So let's go ahead and plot the actual vertex. So 1, negative 1 is right here. Now, if you guys look at the a value is positive. So that means that my U shape is going to go up like this. So let me label my vertex. I'm going to put a V right there so you guys know that's my vertex. And then I am going to draw my axis of symmetry. My axis of symmetry is the x for the vertex, the x coordinate or the x value. So I'm going to put here axis of symmetry x equals 1, because that's what the vertex is at 1 for the x value. So I'm going to draw my axis of symmetry. It's going to be a blue dashed line. You guys have one vertical like this. That's going to cut the parabola in half. So I know that half of the parabola is going to be on the right side. Half of the parabola is going to be on the left side. And it's going to go up because the a value is positive. The next step is find the y value, or the y-intercept. Not the y value, the y-intercept. So I'm going to put here y-intercept, y-int, and that's going to equal my c value in that quadratic function. So let's go back to the quadratic function, or the quadratic equation. The c value is 0 because we don't have a number or a constant at the end of the equation. So my y-intercept is 0. So I am going to plot a point at 0 on the y-axis, and that is the vertex, or not the vertex, the origin. So I have my point y-intercept at 0. Then I'm going to use my pattern to find more points, okay? So look at my pattern. My pattern is 1, 1, and 2, 4. This comes from the parent function of a quadratic function. You guys can see watch my video on this section. But right now, since a is 1, we don't need to multiply the 1 and the 4 by any number. If a is something else than 1, even if it's -1 or something other than 1, you really have to multiply this 1 by whatever the a value is, and the 4 by whatever the a value is. But right now we don't have to multiply. So I am going to go from the vertex. This is my pattern. So I'm going to go 1 to the right, 1 up. So 1 to the right, 1 up, and I make a point right there. Now, if you guys notice, we have reflections right here. Notice that these 2 points are reflections of each other. If you think about the axis symmetry like a mirror. If it is a mirror, these are reflections of each other. There's the same distance from the axis symmetry. 1 unit, 1 unit. Now I need to find another point. So my pattern tells me I need to go from the vertex 2 to the right, 4 up. So from here, 1, 2, 1, 2, 3, 4 up. Right there. Now I do not have another point reflected on this left side of the axis symmetry. So let's just go ahead and reflect it. This point is 2 units away. So I'm going to go 1, 2 units away this way, and I make a point. I connect the dots, and I have my parabola. That is my quadratic function right here. So this is how you graph the parabola. Now the next step is to understand what is the domain and the range of the function. So domain and range, first of all, let's talk about domain. Domain are the x values. I'm going to put here on the bottom of the graph D for domain. It's always all real numbers. For every single parabola, the x values will work. In a quadratic function, any x value will give you guys a real answer. So you guys can say all real numbers work for this function. Now the range are your y values. Now this one, guys, it depends on the vertex and the direction of the parabola. So notice the vertex is right here. What is the y coordinate of the vertex? Let's go back. It's -1. Where is the parabola going? It's going up. So that means that the y values of every point on that parabola is greater than -1, because this is my minimum point. That is the lowest point. Everything else is higher on top of the -1. So my range will be y is greater than or equal to -1. So we use this inequality because the parabola is going up, greater than or equal to. If the parabola is going down, you guys use less than or equal to. And -1 comes from the vertex, the y coordinate. That is your range. Now, let's look at number 6. Question number 6, y equals 2x squared minus 8x plus 4. First of all, you guys notice that everything is empty. The x empty, the y empty. You guys have the cross for the pattern, the vertex, and we need to find the axis symmetry. We need to find the y-intercept and domain and range. So this, guys, is actually for you to memorize the formula to find the x coordinate for the vertex. So notice that I kind of have it set up for you guys. We have a negative, there's the fraction line, and then you guys have equals, a fraction line, and you guys simplify the fraction. So first, let's go ahead and write the formula. What is the formula to find the x coordinate for the vertex? It's negative b, you guys can say opposite of b, over 2a. So I'm going to label my, my coefficients. X squared, the coefficient is a, so we have a positive 2. B is negative 8. And c is your positive 4. Okay, so we do have everything in that equation, a, b, and c. I'm going to substitute and find the x value. So I got x equals positive 2. You guys will have double negatives because the formula has a negative and b is negative. If b is positive, guys, you're only going to have one negative here. So you guys have to be careful with your signs. Always check your signs. Now that I know that x equals 2, that's going to be my x coordinate for the vertex. I'm going to go back and I'm going to substitute this value 2 into every x, this one and this one. So this 2, and I need to find the y value. And for the y value, I got a negative 4. So I substitute the 2 into the x squared, the 2 into the x, I simplify the expression, and we got negative 4. So my vertex is going to be at positive 2 and negative 4. So let's go ahead and plot that point. So on the coordinate plane, you guys see the vertex here. Now, what is the direction of the parabola? Look at the a value. The a value is positive, so that means that the parabola is going to go up. So you guys have the U shape going up. If the a value is negative, you guys will have the parabola going down. Now, my axis of symmetry. So let's go ahead and talk about that. Axis of symmetry. Same value as in your vertex for the x coordinate. So x equals 2, that is the axis of symmetry of the parabola. So I'm going to draw the dashed line through the vertex, and that's always the axis of symmetry. It goes through the vertex and it cuts the parabola in half. The next step, so we have the axis of symmetry, we have the vertex. Now let's find the y-intercept. Now the y-intercept is going to be your c value. So let's go ahead and go back to the c value. My c value is positive 4. So I just put y-intercept is at positive 4 on the y-axis. So on the y-axis, I go up from the origin, 1, 2, 3, 4, right here. Okay, so now that we have the vertex, axis symmetry, and the y-intercept, let's talk about the pattern. So the pattern we use is 1, 1, 2, 4. Now here, guys, notice the a value is not 1. It's something else than 1. And since it's something else than 1, we have to multiply these two numbers by the a value. So right now, a is positive 2. So I need to multiply this by positive 2, this one by positive 2. So on the top, I get a 2. On the bottom, I get an 8. If you guys have a negative number, you multiply by a negative. And that's going to give you guys a negative value, okay? So now, you guys, from the vertex, you're going to go 1 to the right. I'm using the pattern. 1 from the vertex, 1 to the right, and 2 up. So 1 from the vertex, 1 to the right, 1, 2 up. And you guys make another point. Then I go back, my pattern, 2 to the right, 8 up from the vertex. 1, 2 to the right, 1, 2, 3, 4, 5, 6, 7, 8. And I make another point right here. Now you guys are going to reflect those points on the other side. But guess what? This one is already reflected with the y-intercept. Notice, you guys have reflections. This is 2 units away from the axis of symmetry. This point is 2 units away from the axis of symmetry. So we got that, but let's go ahead and reflect this one. This point here is 1 unit away. So on the other side, 1 unit away, you guys reflect. So we got our parabola. You guys are going to make your U shape like this. And you guys have yourself the quadratic function. Let's talk about domain. Domain will be all real numbers right there. My range, that's R for range, is going to be y is greater than or equal to, and I'm saying greater than because the parabola is going up. If the parabola was going down, you guys used a less than or equal to. Now, what is the y coordinate for the vertex? So here's my vertex, and the y coordinate is negative 4. So my range will be y is greater than or equal to negative 4. So guys, when you guys graph a quadratic function, there is a lot of work to do, but make sure you guys know how to find the vertex of the quadratic function, how to find the axis of symmetry, how to find the y-intercept, how to use the pattern to find more points on that parabola and then reflect the points. And then you guys also need to understand the domain and the range. So I hope you guys are well. I want you guys to practice. I want you guys to always do your homework, and I'll see you guys later.